GCSE Physics boosters, hazards of radiation. So this video is about why nuclear radiation is dangerous and how you can deal with it safely. Now, nuclear radiation is dangerous because it is ionizing. You should know what an ion is. And basically, if you've got an alpha beta particle whizzing along and it smacks into an atom and it knocks off an electron. So it creates an ion pair. It creates an electron and a positive ion. And basically, you've banged into this atom and you've changed it. Now, you haven't made it radioactive because you've done nothing to the nucleus. Being exposed to radiation does not make something radioactive, okay? But it will ionize atoms. And if those atoms happen to be in the cells of your body, then basically it can do an awful lot of damage to that cell. And a single alpha particle might ionize thousands of atoms, okay? Now, inside our cells, there's all kinds of chemical reactions going on. There's all kinds of molecules that do important jobs inside your cell. There's all kinds of little organelles and things doing this, that, and the other. And if too many atoms are ionized, and then too many molecules don't do the jobs properly, then that cell could be destroyed. That cell doesn't do its job anymore. It is destroyed. Now, different types of radiation are dangerous in different ways. Now, you should remember that alpha can't get through paper and it can't get through your skin either. However, it will do a lot of damage to your skin. Okay, it'll do lots of ionizations in a very, very small area, and it will do lots and lots of damage to your skin. If it actually gets inside your body, if you eat something which is emitting alpha, or if you breathe in some smoke which contains radioactive stuff, it will do a lot of damage inside your body. Okay, now beta isn't as dangerous because its damage is more spread out. Remember that beta has a bigger range in air. And if you were exposed to beta particles, they would penetrate a few centimeters and their damage would be more spread out. Still going to make you ill, depends how much of a dose you get, but alpha is certainly the most dangerous. Gamma would probably go straight through you, okay? A very, very large dose of gamma, then it's likely to do quite a bit of damage. But a small dose of gamma would probably just go straight through you and not interact with any of your atoms at all. Now, exposure to large amounts of radiation, if lots and lots of your cells are destroyed, then you get radiation sickness. And that could make you very ill or even kill you. Okay, this person on the left has been exposed to quite a strong radiation source. The guy in the middle was actually assassinated. He was injected with some radioactive isotope and he died a couple of weeks after this photo was taken. And I think these people on the right are from somewhere like Hiroshima or Nagasaki after they dropped the bomb. So they have radiation sickness, which is skin burns, and inside their bodies there's lots of damaged cells as well. Now, the amount of radiation you are exposed to is called the dose. Radiation dose is measured in sieverts, SV, or more commonly millisieverts. 1 sievert is a massive dose. Okay, so more commonly we use millisieverts. And you may get this dose in a very short period of time, like if you're next to an atom bomb going off, or it could be over many years. Let's say you work at a nuclear power station. Okay, so this dose, imagine it's like a dose of poison. and it might be a lot of poison very quickly or a little bit of poison over many, many years. And the dose is measured in sieverts or millisieverts. Nuclear radiation may cause cancer. Now, the chromosomes inside your cell's got a nucleus, and in the nucleus there are these bits of spaghetti called chromosomes, and they control just about everything that your cells do. Okay, and one thing they control is how often the cells reproduce. In other words, when the cells die. And basically, if those genes get damaged, then what might happen is that the cell reproduces and reproduces and reproduces again and again and again uncontrollably. And this ball of cells takes over your body, and that's what cancer is. This unfortunate person down there has some kind of skin cancer. These barrels contain nuclear waste from a nuclear power station, and it's basically radioactive stuff that you can't use anymore. So it might be fuel rods which have been used up. They're not active enough to be used anymore. That's high level waste. Or it might just be low level waste. It might be the clothing that people have used to protect themselves. But basically, these barrels contain quite a lot of nuclear waste. And the stuff in these barrels has to be contained, and it has to be looked after. Because if it gets into the environment, if it gets into the air that we breathe, or the water that we drink, or the air and the food the things that we eat, drink, then basically they would be contaminated. This radioactive stuff would get into their bloodstreams, it would get into our bloodstreams. If it's released into the environment, it would contaminate our air and food and water supplies. It needs to be stored securely away from people, and some of it for thousands of years. We talked about half-life, and some of these isotopes have half-lives of thousands of years. Okay, plutonium, one isotope of plutonium has a half-life of about 200,000 years. Okay, and this stuff, you can't let it fall into the hands of terrorists, and you basically can't let it leak into the environment either. Accidents can happen. In 1986, the reactor at Chernobyl nuclear power station basically caught fire, and lots of radioactive smoke spread out, and these clouds of radioactive smoke got all the way to Scotland. Okay, and even now the reactor is you can't get anywhere near it. It's very, very dangerous, giving off lots and lots of radiation. They've actually tried to contain it. They've built a building all around it. Okay, but accidents happen, and if this stuff is released into the environment, it can contaminate basically everything. This doctor uses radioactive materials. She works in a medical physics department in the hospital. Now, what precautions does she take to limit her exposure so that she doesn't get a big dose of radiation? What things do you think that she does to protect herself? And I'll give you a list of them in 3, 2, 1. Okay, now the radioactive stuff is kept securely. Usually it's kept in lead-lined containers to try and stop the radiation getting out. The doctor doesn't handle anything with her bare hands. She will use tongs, tweezers. She'll always wear gloves because alpha can't get through gloves. The time that she is in danger of being exposed is minimized. So she doesn't leave things lying around. As soon as she's finished with it, it gets put away. The time that she is in danger of being exposed is minimized. Minimize the time. She had special training. She knows exactly what she's doing. She knows how to handle the material safely. And she wears a dose meter. She wears a detector on her clothing which measures the amount of radiation that she's exposed to. And perhaps if she does get exposed to a lot of radiation, then an alarm may go off. But basically, at the end of the day, they check the dose meter to see how much she has been exposed to. Despite that, there are some professions. If you work at a nuclear power station, you're going to be exposed to a lot more radiation than most people. And that's part of your job. Okay, if you don't want to do it, then don't do it. So some professions do involve being exposed to more radiation. If you're a pilot, you're exposed to a lot of radiation because a lot of radiation can't get through the Earth's atmosphere. But if you're high up, then you get more radiation. If you're an astronaut, you get blasted with a lot of radiation from the sun. Which leads us on to this, background radiation. We are all exposed to small amounts of radiation all the time from natural sources. So there's rocks in the ground which contain radioactive stuff. They can emit gases. So there's gases in the air which are radioactive. There's radiation from space. The sun gives off a lot of radiation. We're very lucky that the Earth's magnetic field protects us. Okay, most of this radiation just bends around the Earth because of its magnetic field. If you're an astronaut, you get a big dose of radiation. Then there are man-made sources as well. This map of Europe, bottom left, and it shows where the cloud of radioactive fallout from Chernobyl, how it covered basically most of Western Europe, and from nuclear weapons testing. Okay, so nuclear accidents and nuclear weapons testing. There's Fallout Boy. I'm into my computer games. Fallout Boy, he is. Now, this is the kind of data which you might have to analyze in an exam. If you look at this table, it gives you the dose due to various things. From if you eat a banana, there's a little bit of radioactive potassium in a banana. There's chest x-ray. There's your body contains potassium. So you get a dose of radiation from the potassium in your own body. If you get a CT scan, yeah, big dose of radiation. Normal background is about 4 millisieverts. Notice that if you work in a nuclear power station, you're allowed up to 50 millisieverts a year. If you get more than 400 millisieverts in a short time, that can make you ill. If you get 8,000 millisieverts or 8 sieverts, it will kill you. Okay, a small dose of radiation is unlikely to hurt you, but basically the bigger the dose, the bigger the risk. Yeah.